All right. So what if, my super awesome test file there was so big that it filled up the whole disk and now we need more space, right? This is one of the things that I think is really helpful and probably one of the most common things that I've seen LVM used for to kind of save the day on a Linux system. And that is this flexibility that it gives you to expand and even contract disks. Now, yes, we've had lots of conversations about how XFS can't be contracted, but you can certainly, when you add space to a volume group or a logical volume, if that logical volume is then removed or whatever, or you added too much space, you can always take that back out again, right? It's just the file system underneath that will sometimes give you trouble there. But we're going to go ahead and we're going to take my volume group that I just created and we're going to add another disk to it. So let's do a vgextend. See what I mean about these simple command names. VG0, because we got to tell it what volume group we want to change. And we're just going to add another physical volume to it. And like I said, we've got a couple of these loop devices. You see that there's loop 0, 1, and 2. We're going to add loop 1 because loop 0 is already in there. And then what it's going to do is it's going to simply take the volume group and say, oh, look, I forgot to make a PV on there. And it did it for me. That's handy. I didn't know it would do that.
Yeah, so remember a while ago we were doing file system stuff and we were trying to break it and it would like not overwrite an existing file system without
Yeah,
warning.
and what
Well,
the
we've
heck?
done the same thing with logical volume stuff. It's what are all the rakes someone steps on and smashes themselves in the face with? Let's stop doing those things.
But all those broken noses I've gotten over the years feel like they're completely in vain now.
Well,
Well,
we're making
anyway,
it for new people.
luckily it just worked. I didn't have to make the PV. Normally, the procedure would be you make a PV on that disk and then you add it to the volume group, but it just did it for you. So that's handy. I guess I don't know what would happen if there was, hopefully, it would check if there was already a file system there or something.
If there
That could
is
be
a
awkward.
volume group descriptor area and it belongs to another volume group, it will error out and not let you add it to this one.
Okay. All right, so VG display now again on VG0, and we should see that there is an additional 511 extents because that's about the size of the additional space that we added, right? So you can see here, we've allocated 511. That's what I did in the critical path. And now there's an additional 511. That's that new disk that I added. Now, if the new disk you added is even slightly different in size from the first disk you added, that the number of physical extents that are available is going to be different, right? This is just because I literally made these exactly the same size. They're all exactly the same block devices.
And that's actually one of the other cool things about logical volume management is you can use physical volumes that are of different sizes, and the logical volume manager won't care. It'll just chop them up into the allocatable PE size that you see here in this output. That's the physical extent size. And so if it's 2 gig or 20 gig or 500 meg, it'll chop it up into those extents and throw it into your storage pool.
Right.
Nate, real quick, we did get, thanks to Rick Green and Shantanu, a revised how do we get this in JSON.
Yeah.
So if you do a VGS -- report format space JSON on your volume group name.
What did I typo? Anything?
I think it
Looks good. There you go. Those
boom.
of you who love JSON. What was the point of this?
Shantanu was like, if only these commands would output, and I was like, challenge accepted.
But
But
why? Who likes JSON?
I mean,
Apparently Shantanu.
uh, Ansible loves JSON. Python people love JSON. So there's a lot
Yeah,
of places
I guess.
JSON's popular.
I guess.
All right,
Okay.
sorry, I didn't mean to interrupt your demo.
All right. So we added an additional PV, which it created for us, which was very handy, to our volume group. Now, and we showed that there's additional space there. Now, there's a couple things you can do with that space. You can extend a logical volume. If LV0 was full and I just wanted to make it bigger, I could extend LV0 into some of those free extents, all of them, some of them, whatever I want to do. Or I can make a new logical volume. So say it's actually that I need another partition for something, but I forgot to do it the day that I provisioned this machine. The security compliance people came back and said, home really needs to be its own partition or something, right? What I can do is I can add that disk. I can add it to the volume group like we just did. Or I can make a new volume group if I really wanted to. You can have several volume groups on the same system. And then you can make another logical volume. And what I'm going to do is I'm going to make an additional logical volume inside of this volume group. So we're just going to do the LV create again. We're going to do -L 511 because that was how many extents we had available. We're going to give it a new name of LV1 because LV0 was the other one that we did. And we're going to tell it to do it inside of VG0. Now, obviously, if I had instead extended the LV0, then the file system on LV0 would also have to be extended into the new space. And there's additional commands to do that, which I neglected to look up before the show, which is why I'm not extending XFS instead. Okay, so now if we do another LV display, we should have 2 logical volumes. I think if I just do VG0, yeah, there we go. It'll give us 2 logical volumes. We've got good old LV0 that we had before and LV1 that's here, now that we've added the additional space. All right. Any questions we need to answer before I move on? I was going to go into how do we move that data if we wanted to?
So as though by magic, one of our viewers, which is
XFS
Tech
Pro. Yep.
Pros YT, was teeing you up for this, and they asked, what would happen if I removed a physical volume and now my data is gone? And my original response was, well, you would have had to work really hard to do this, because if you just try to remove a physical volume, it will error and say, I can't do that because there's data on this thing.
Right.
And the recommended process would be to use PV move, which Nate is about to show us.
Right. So I could try to do a PV remove just to show you, but do you think it'll explode?
No, it should error because it's in use. That would be my expectation.
What was it? Dev loop 1 was the additional one that I added? Right. So what PV remove does is it just goes to the block device and says that metadata that's on there, take it away. Right. And then, of course, the rest of the tools will realize that thing is no longer part of the volume group. Now, if I do this, yeah, okay. PV dev loop 1 is used by VG, VG0. Please use VG reduce first, right? So in this case, I've already created a logical volume that uses these extents. So I have to delete the logical volume, or I'd have to shrink them all to the point where they're small enough to fit on one physical volume. And then I can do VG reduce to take away those 511 extents. And then, only then, should PV remove allow me to remove this disk, right? Because it knows that what's going to happen here is I'm going to cause file system damage.
And I love that it's so against the grain to actually do it this way. That's like, if you really want to, not only do you have to specify -- force, you use -- force twice in a row.
That is nice. Because why would you do that? Why would you forcibly remove the PV if it knows you're going to lose data?
Yeah, so I have seen a similar-ish situation, which
Right.
is somebody removes the disk, like physically or in the hardware or the storage array that
Oh,
you're
right.
attached to. Like those guys disconnect it from your machine and now you've lost it.
Yes.
So that's a slightly different situation because there you're not actually working with the logical volume stuff, you're working with hardware stuff. And in that situation, if they disconnect the device from your machine, the device data is still right, assuming they didn't destroy it or something silly. But if they just disconnected it, you should be able to connect it back again. And the volume group descriptor area that's on the physical volume that tells it what volume group it belongs to and how big it is and what physical extents are in use, all that metadata is still intact. So now
Right.
that it's been connected back with your machine, you could try rebooting, because then all that stuff gets reinitialized and it'll scan the disks and see the disk has been added back and fix it. You might be able to do something like a VG import something,
Well,
but
there's
that
a
yeah.
bunch of sort of troubleshooting tools that we're not covering today that let you do things like activate and deactivate specific logical volumes and volume groups, that scan for physical volumes, scan for volume groups. You could probably do some concoction of those things to bring that volume back in if you absolutely can't reboot. But rebooting would probably also do it because all that stuff should get done at boot time. Personally, I don't like to reboot a machine unless I'm sure it's going to come back. And if I've just plugged the disk back in, I'm not sure it's going to come back. I would probably try all the other options before I try to reboot.
Yeah. The other thing is, if that happens and somebody like yanks a disk out of the volume group and disconnects it from your box, all of a sudden you'll start getting a lot of error messages in your log
Yeah.
complaining that disk UUID whatever is no longer accessible, and anytime you interact with that volume group, it will be very sad.
Yeah, I've had this happen. We had the snapshot chain on a VM get messed up. So the VM was running just fine, and then all of a sudden the snapshot chain was broken, and there was data from the disks just vanished because the snapshot chain got broken. I don't know how it happened. I forget exactly what the circumstances were, but it took me some time working with Red Hat support to try to figure out how to resolve this thing. And sure enough, we got it back. We got the data back. Pretty cool.
Awesome.
All right, let's see what was next on my list.